Hello, a very important start to a very important unit. I can draw conclusions using my 6 definitions. My 6 definitions, are given right here. So if you want to take a moment and maybe do a screenshot or copy these down, of course you have them in the front of your packet as well. We're going to talk about each of them. We're going to get practice with them, and then we're going to move on. So, a midpoint. A midpoint is exactly what it sounds like. A midpoint is a point that's directly in the middle of a line segment. So if J is a midpoint, that means that J is halfway from D to R. So what that means is that from D to J must be congruent to from J to R. So my conclusion is DJ is congruent to JR. And the reason a midpoint creates two congruent segments. So whenever they give you that something's a midpoint, your reason is going to be a midpoint creates two congruent segments, and your conclusion is going to be what those two congruent segments are. It's going to be endpoint to midpoint equals midpoint to endpoint. Number 2, they're all pretty much the same. It says that O is the midpoint of JE. So if O is the midpoint of JE, that means that O cuts JE in half. So this half, JO, is congruent to this half, OE. So my conclusion is JO is congruent to OE. And the reason a midpoint creates two congruent segments. I want you to take a moment, try number 3 on your own. You can pause this video. Pause it. Okay, so if E is the midpoint of MG, that means that a midpoint creates two congruent segments. So my conclusion is that ME is congruent to EG. And the reason a midpoint creates two congruent segments. All right, so that's it for midpoint. Let's move ahead to line bisector. So let's talk about the English language. AO bisects TC. Well, let's get to the English language in a moment. Bisect. What bisect means is cuts in half. Okay, in general, the word bisect means to cut in half. So the question is, what's being cut in half? Well, let's talk about the English language. If a student punches Schlansky, who gets punched? Does the student get punched or Schlansky gets punched? Schlansky gets punched. That's the way the English language works. Whatever comes after the verb is what the verb is being applied to. So again, if a student punches Schlansky, Schlansky gets punched. If a student bisects Schlansky, Schlansky gets bisected. If AO bisects TC, what's being bisected? TC. So TC is what's being bisected. TC is what's being cut in half. So if TC is cut in half, what are the two congruent halves? Well, TS and SC. So my conclusion is TS is congruent to SC, and my reason, well, it didn't say midpoint, it said bisector. So a line bisector creates two congruent segments. So it's pretty much the same definition as midpoint. A midpoint and a line bisector both create two congruent segments. However, if it says that it's bisecting, then we're writing a line bisector. If it says that it's midpoint, then I'm using midpoint. NL bisects FA. NL punches FA. Who's being punched? FA. So FA is what's being cut in half. If FA is what's being cut in half, my conclusion, FS is congruent to SA. My reason, a line bisector creates two congruent segments. Now we're going to talk later about an angle bisector. How do I know that this one's a line bisector? Well, since FA is what's being bisected, FA is a line segment. That's why it's a line bisector. If an angle is being bisected, then it's going to be an angle bisector. Try number 3 on your own. Feel free to pause it and unpause when you're ready. Okay, NC bisects AH. At this point, you should have tried this one on your own. If you haven't tried it on your own already, just pause it and try it on your own now. If NC punches AH, AH is punched. If NC bisects AH, AH is what's being bisected. So if AH is cut in half, then my conclusion is that AO is congruent to OH, and my reason is a line bisector creates two congruent segments. Let's skip ahead to number 5. Let's go back to me and the student. I don't know what world I'm living in where I'm having fist fights with students, but it's entertaining to think about. So if Schlansky and a student punch each other, who gets punched? Well, both of us get punched. If me and a student bisect each other, who's being bisected? Well, both of us. If QU and SE bisect each other, what's being bisected? Both of them. So there's going to be two conclusions. If QU and SE bisect each other, well, for starters, QU is being bisected. If QU is being bisected, then QO must be congruent to OU. If SE is being bisected, then SO must be congruent to OE. Now, as far as notation, I put 1 dash on QO and OU. If there's a second pair of things that are congruent, then I mark them each with 2 dashes. If there was a third pair of things that was congruent, I would mark those with 3 dashes. What's my reason? Well, since lines were bisected, I'm using my line bisector definition, which is a line bisector creates two congruent segments. All right, let's move on to median. So there's 2 important things to know about median. It's important to know what a median does, and it's important to know what a median is. In this course, it's very important to understand what a median is. For this lesson, it's more important to know what a median does. So what it is, a median is a line segment that connects a vertex to the midpoint of the opposite side. So that is something that's very important to understand in this course in general. A median is a line segment. It's a line segment that goes from a vertex to the midpoint of the opposite side. That's what it is. That's not as important for this lesson as what it does, since it goes to the midpoint, and we know that a midpoint creates two congruent segments, a median also creates two congruent segments. So that's your definition for median. A median creates two congruent segments. Notice that all the definitions we've done so far are all exactly the same. A midpoint, a line bisector, a median, they all create two congruent segments. So, where am I? If SA is a median, that makes A a midpoint. CA is congruent to AT. Now the reason is not what I wrote in the bottom right here. It's that a median creates two congruent segments. So again, there's what a median is, and there's what a median does. What it is right here. That's important in this course overall. A median is a line segment that connects a vertex to the midpoint of the opposite side. For this lesson, what I'm more concerned about is what it does. And what a midpoint does is it creates two congruent segments, just like a midpoint, just like a line bisector. Number 2, OS is a median. So, if OS is a median, I know that a median creates two congruent segments. Since OS is a median and S is a midpoint, my conclusion is that DS is congruent to SG. And my reason, a median creates two congruent segments. All right, I want you to try number 3 on your own. If you need more time, please pause it. Okay, now that you tried number 3 on your own, if OK is a median, well, a median creates two congruent segments. Since K is the midpoint, that's the definition of a median is. MK is congruent to KN is my conclusion, and my reason, a median creates two congruent segments. All right, I want to skip ahead to number 6. 6 is a little tricky. I want you to try on your own. I want you to try it on your own. So pause this video and try it on your own. And when you're done, unpause it. Okay, now that you tried it on your own, there's a little twist in this one. Let's see if you got it right. I gave you that AO is a median. So I know that a median creates two congruent segments. The two congruent segments, since O is in the middle, what that means is that endpoint to midpoint is the same as midpoint to endpoint. So that S is irrelevant. My conclusion is GO is congruent to OT, and the reason, a median creates two congruent segments. So your two congruent segments are always going to be endpoint to midpoint, midpoint to endpoint. Any points in the middle are irrelevant. All right, let's move on to angle bisector. If BA punches angle CAD, who's getting punched? Angle CAD. If BA bisects angle CAD, what's being bisected? Angle CAD. So for angle bisector, it's really important to find the vertex of the angle that's being bisected. The vertex is always the middle letter. So since A is the vertex, this is angle CAD, and my two congruent angles are right there at that same exact vertex. So when I name them, since they all have a vertex of A must go in the middle. So that top one, I'm going to call CAB, is congruent to that bottom one, I'm going to call DAB. With angles, these letters, the order of the outside letters don't matter. Instead of DAB, I could have called it BAD. Instead of CAB, I could have called it BAC, but A must be in the middle. My reason, well, since an angle was being bisected, it's an angle bisector, and an angle bisector creates two congruent angles. So if an angle is being bisected, if you see an angle after the word bisect, it's an angle bisector. And since an angle is being cut in half, we're getting two congruent angles. If there is a line segment after the word bisect, that would be a line bisector, and that would be two congruent segments. 2. ES bisects angle KSY. ES punches KSY. KSY is what's being punched. Since it's an angle, it's going to be an angle bisector. What's the vertex of angle KSY? S. So I go to S. That's my original angle. My two congruent angles are right there at that same vertex. So what letter must go in the middle for each of those? S. Angle KSE is congruent to angle YSE, an angle bisector. Creates two congruent angles. Try number 3 on your own. Again, try number 3 on your own. Okay, if you're still working, pause it. EA bisects angle DIV. So DIV is what's being bisected. The vertex of DIV is I. So I go to I. That's my original angle. Those are my two congruent angles. So my conclusion is angle EID is congruent to angle EIV. And my reason, an angle bisector creates two congruent angles. That's it. There's just one more I want to go over with you. And that would be number 8. I want you to try it on your own first. Okay, if you need more time, pause it. All right, now that you tried number 8 on your own, the picture looks like two angles are being bisected. It looks like angle O and it looks like angle N. But you can't go by what it looks like. You have to go by what they give you. It says that HN bisects angle ONC. If HN punches ONC, ONC is what's punched, ONC is what's bisected. So I'm looking at N. Those are my two congruent angles. It doesn't say anything about O. You might be saying, well, it looks like O is cut exactly in half, but I don't know that. I can only go by what they give me. I'm not going to write out the rest of it. I just wanted you to understand that concept. You can only go by what they give you. All right, which brings us to this symbol, this upside down capital T, which is going to be a very important symbol throughout the rest of this course, and that is the symbol for perpendicular. And basically, what you need to know about perpendicular is that perpendicular lines form right angles. So my definition is going to be perpendicular lines form congruent right angles. Since I have two right angles formed, if they're both 90 degrees, then they must be congruent. So all you have to do is find the right angles. The right angles are where the perpendicular lines meet. So if RW I make green and DE I make red, at what letter does the green touch the red? The right angles are at W. So when I name them, W must be in the middle since that's the vertex. I'm going to call them DWR is congruent to angle EWR. And again, the reason, perpendicular lines form congruent right angles. Number 2, it's telling me that MI is perpendicular to RA. So I need to find where MI and RA meets. MI I'll do blue, RA I'll do purple. Where are the right angles? Where does the blue hit the purple? I. So I is the vertex, so I must go in the middle for each. Angle MIA is congruent to angle MIR, and the reason, perpendicular lines form congruent right angles. Number 3 is a little different. There's two pairs of perpendicular. The first one is KA and AE. Where does the blue and the black meet? Well, they meet at A. However, there's only one right angle at A. Well, now I have another pair of perpendicular, AE and ET. So AE is black, I'll make ET blue. Where does the black meet the blue on the right-hand side? At E, and there's only one right angle there. So the right angles don't have to be next to each other. If they're both right angles, then they must be congruent. So I can say that angle KAL is congruent to angle TEL, perpendicular lines form congruent right angles. Now, as far as naming them, there's plenty of ways you can name these angles. So this angle right here, for example, A must be in the middle, but you can call it KAL, KAE, LAK, EAK. There's a ton of different correct ways to name it, but A must be in the middle for this one, and E must be in the middle for that one. We're going to try one more tricky one. This one we can do. This one's a little tricky. I want you to try it on your own, and then we'll go over it. So please pause, and when you're done, unpause. Okay, at this point you should have tried number 4 on your own. KN is perpendicular to VE. I know that perpendicular lines form right angles, so I just need to find my right angles. My right angles are where the perpendicular lines meet. So KN is blue, VE is green. At what letter are my right angles? That A in there is just to mess you up. The right angles are where the perpendicular lines intersect. So N is the vertex, so N must go in the middle for each of them. I'm going to call it VNK is congruent to ENK. Again, there is more than one correct way to name the angles, but N must be in the middle for both of them. In my reason, perpendicular lines form congruent right angles. All right, we got one more definition to go through, and that is altitude. And altitude is essentially the exact same thing as perpendicular. So we talked about median before. There's what it is and what it does. Same thing for altitude. Let's first talk about what it is. An altitude is a line segment, just like a median, that extends from a vertex, just like a median, and is perpendicular to the base. A median is a line segment that goes to the midpoint. An altitude is a line segment that's perpendicular to the base. So since it's perpendicular to the base, my definition, what I'm going to actually use in proofs, is an altitude creates congruent right angles. So it's essentially the same definition as perpendicular because an altitude is always perpendicular. So my right angles are where the altitude hits the base. So my altitude is MI. Where does MI hit the base? At I. So angle MIA is congruent to angle MIR. And again, the reason an altitude creates congruent right angles. Let's just do one more for altitude. It's really, again, the same thing as what we were just doing for perpendicular. I guess we can do number 2. If yn is an altitude creates 2 congruent right angles. So the right angles are where the altitude hits the base. So yn is the altitude. This is your base. The right angles are at n. So angle YNR is congruent to angle YNA. And altitude creates congruent right angles. So those are your 6 definitions. It's very important that you know them and are comfortable drawing conclusions from them in order to do the next step. And you need to be comfortable with that step to do the step after that. You have to be comfortable with that step to do the step after that. Again, it's going to build and build and build. But these 6 definitions are the foundation, and they're all pretty much the same definition. The first 3 are exactly the same. A midpoint, line bisector, and median all create 2 congruent segments. And then you have these 2 are exactly the same. Perpendicular lines and altitude create congruent right angles. And then angle bisector is just kind of a combination of those. It just creates 2 congruent angles. Make sure you know your definitions. Make sure you practice drawing your conclusions. Refer back to this as much as you need to. And enjoy the rest of your day.